Hello and Assalamualaikum. Today I will be presenting our project titled IoT-based animal intrusion detection system for agriculture farm. So, agriculture is very important in Malaysia, especially for small-scale farmers who depend on their crops as their main source of income. So, however, many of these farms are located near forest areas which make them highly exposed to animal intrusion. Animals such as wild boar, monkey, and stray animals often enter farm area, especially during nighttime. When this happens, crops can be eaten, trampled, or destroyed within a very short time. For farmers, this kind of damage is a serious problem because it directly affects their harvest and income. In some cases, one night of animal intrusion can wipe out a week or even a month of harvest. So, most farmers still rely on traditional methods such as fencing or manual checking. Unfortunately, these methods are not very effective against the animal that can climb, dig, or break through the barrier. On top of that, farmers usually only notice the intrusion after the damage has already occurred, which means it is already too late to prevent the loss. So, because of this, there is strong need for a smarter and more reliable solution that can detect animal intrusion early. This is why this project focuses on developing an IoT-based animal intrusion detection system. The system is designed to monitor farm areas continuously and send real-time alert to a farmer when animal movement is detected. So, with this system, farmers can take immediate action and reduce crop damage, helping to protect their farm and livelihood more effectively. So that's all from me. Thank you.
For objective, first, create an IoT system to detect both animal and human intruders in small farms. Next, provide instant mobile notifications the moment an intrusion is detected. Test the accuracy of using PIR and alternate sensors together. Use the Blink platform to link the system to the farmer's smartphone. Finally, test system performance in a controlled dummy farm environment. For scope of work, design system using prior electronic sensors and components. Next, integrate PIR and ultrasonic sensors for movement detection. Code the microcontroller to process data and control alerts. Finally, use a buzzer and LEDs for local warning signals.
The problem for the small-scale farmer is first the ineffective of security, where they cannot take care of their farm or crop for 24/7. And then there are also problems with high-cost technology, which is the industrial IoT are too expensive for them, for example, like electric fence. And lastly is the infrastructure. Usually for the small-scale farmer, they don't have hand of the infrastructure like continuous AC power supply to use IoT system. Okay, now we go for the step analysis. So first is the social and technology, where first social, we are empowering farmer who let time and labor by using technological investment, which is by using ASP-based IoT system that provide immediate alert, which is a blink notification. So we making a smart farming accessible even in a remote or off-grid area and also through power of the solar panel. And then we go for the economic environmental. Economically, the system is a low-cost investment that prevent a high-cost crop loss. It is also environment sustainable, which we using 100% solar energy, so zero carbon footprint. And also, when we deter, we aren't using dangerous chemical or electric fence to deter animal way, but just use buzzer and light. And lastly, political, where this project align with the current government initiative for rural digitalization.
Hello and Assalamualaikum. Now I will show the list of components and the total cost used in our project. So for detection, we use an ultrasonic sensor, PIR sensor, ADR, and laser diode to detect animal movement and interaction. The ESP32 acts as the main controller to process the sensor data. When an animal is detected, an active buzzer and LED are activated to alert and scare the animal away. So a breadboard is used for easy circuit connection during prototyping. So for power supply, the system uses a 12-volt battery, solar panel, and solar charge controller, allowing the system to operate continuously in outdoor farm areas. So overall, the total cost is RM133.43, which makes the system low cost, practical, and suitable for small-scale farmers.
Okay, now I will explain about the main component of our IDP project. So first of all, we have a panel solar that used for charge our battery solar. Okay, so now we go to the indicator of the solar battery. So we can clearly see the battery is low because it's a night schedule. So the battery is low. So we can see the main component of this project is used ESP32. So the ESP32 is connected with the other sensor, which is PIR and ultrasonic sensor. So from this connection, we can see clearly from the right side we have the buzzer. So the buzzer will give us the sound when any intruder comes, and from the above we can see the green LED light that synchronized with the buzzer that will light, and the buzzer will sound clearly if any intruder comes.
First, I will demonstrate the function of LDR sensor. From the video, we can see that the buzzer and the light are functioning because on one side there is a laser source directed towards the LDR. When the laser beam is interrupted, which happens when I pass between the laser and the LDR, the light intensity received by the LDR decreases. This change causes a variation in the resistance of the LDR, which then triggers the circuit to function as designed. In the second section, I will conduct testing for the PIR sensor and the ultrasonic sensor simultaneously. Now we go. In this demonstration, I will stand in front of the both sensor. The PIR sensor detects human motion, while the ultrasonic sensor measures the distance of an object in front of it. When my presence is detected by both sensors, the system responds by activating the buzzer as an alert indication and the LED.
When the sensor of the system detects any intrusion, they will send a blink notification at user devices.